When you're talking to an AI like ChatGPT, what are you really talking to? It might feel like something totally alien, but what we're finding out is that its blueprint, well, it's actually pretty familiar. We're about to dive into the incredible parallels between today's most advanced AI and the one thing we know best, our own brain. And you might be surprised by the reflection you see in that mirror. So really, how is an AI like a human brain? And look, this isn't just some cute metaphor we're using. The similarities in their core design and how they actually work are so deep, it seems like in our big quest to build artificial intelligence, we might have accidentally built ourselves a mirror.
Okay, so to really get our heads around this, we're going to break it down into 4 key areas. Think of this as our mind map, our guided tour through the shared architecture of both these minds, one biological, one artificial.
All right, first up, let's talk about the actual structure. How are these systems even built? We're going to look at the fundamental building blocks, comparing the body of the brain to the body of the AI.
Okay, get this. Both systems use the same brilliant trick, modular design. In your brain, the neocortex, that's the part that does all the heavy lifting, the higher thought, is made of countless repeating little circuits. A transformer AI? It copies that exact same strategy, using what they call stacked layers that are all just slight variations of the same basic block. It's just an incredibly smart way to build something complex. You design one good part, and then you just copy it over and over.
So with all those layers, how does information actually get through without turning into a game of telephone? Well, the brain uses these things called white matter tracts as basically information superhighways. And AI has an almost identical feature called a skip connection. Both of them act like express lanes, letting the original, big picture idea literally jump past several layers of nitty-gritty processing. This makes sure the main point, the core message, never gets lost in all the noise.
Okay, so having a complex structure is one thing, right? But how does it know what to actually focus on? And that brings us to our second stop on the map, the attention engine. This is the all-important filter that figures out what matters and what doesn't.
Think about it. With so much input coming in all the time, how does any system know what to pay attention to? Well, in your brain, you've got this little gatekeeper called the thalamus. It's like a switchboard operator, deciding which sensory data, like the sound of my voice versus some random noise in the background, is actually worth your conscious focus. An AI's self-attention mechanism? That's its thalamus. It scans a sentence and, on the fly, decides which words are the most critical for understanding the whole meaning.
But here's where it gets even cooler. AI takes this a step further with something called multi-head attention. It's exactly what it sounds like, the ability to track a whole bunch of different relationships between words. We're talking grammar, tone, facts, all at the same time. It's like having multiple spotlights of attention all scanning the same sentence, but each one is looking for a different kind of meaning, and it's all happening in parallel.
And here's a great way to think about it. Imagine you're listening to your favorite song. You're not just hearing a mess of sounds, right? You're simultaneously tracking the melody, you're understanding the lyrics, and you're feeling the rhythm of the drum beat. That kind of parallel processing is exactly what multi-head attention gives to an AI.
All right, for our third stop, we are heading into the library. This is all about memory, how both of these systems hold on to information for right now, and how they store knowledge for the long haul. Every system needs a scratch pad, a place to jot things down for a second. For us, that's our working memory. It's that mental space where you hold a phone number just long enough to dial it. For an AI, that's called the context window. It's the active workspace holding the current conversation, and it's what allows the AI to remember what you literally just said.
But, and this is a big but, that workspace has its limits. Just like this quote says, once the conversation gets too long and goes past the size of that window, the AI's memory of the early parts of the chat, it's just gone. It's why sometimes a chatbot might seem to totally forget what you were talking about just a few minutes ago.
So what about long-term knowledge? Now, this is where the parallel becomes absolutely mind-blowing. Your memories, your knowledge, they aren't files stored in some folder in your head. They exist in the physical strength of the connections between your neurons. And an AI's knowledge works the exact same way. It's baked into the connection strengths, the weights, between its nodes. When it knows something, it is not looking it up in a database. The knowledge is the very structure of the network itself.
And for our final stop on this tour, let's look at the flow of information itself. How does all this raw data get turned into real, sophisticated understanding?
So after that attention mechanism has shined a spotlight on what's important,
What happens next? Well, that information gets handed off to these little specialized processing units. In an AI, they're called feed-forward networks. You can think of them as a bunch of small, focused workshops. Each one takes one specific piece of information that attention has highlighted and just works on it, refining its meaning before passing it up the chain.
And this is how it all comes together. It's beautiful, really. Understanding is built up hierarchically, layer by layer. The first layers see really simple stuff, like the edges of an object in an image, or just individual letters in a text. Then the middle layers combine those into bigger things, like shapes and words. And finally, the top layers take all of that and synthesize it into abstract concepts and the overall intent. It's a ladder of understanding, from simple to complex.
So when you put it all together, the modular design, the attention filters, the way memory is literally encoded into the structure, it's pretty hard to ignore. The AI's architecture really is a mirror. It might be a simplified one for sure, but it's a recognizable reflection of our very own neural blueprint.
Which, of course, leaves us with one final fascinating thought to chew on. If the blueprint for our most powerful new technology is starting to look so much like the blueprint for our own minds, it kind of forces us to ask a really profound question. So the next time you talk to an AI, remember this stuff and just ask yourself, what are we really building here?